Now let's go back and talk about this assumption that the total energy was conserved. How many of you have been told in an earlier class that energy is always conserved? I was taught that. And that is true in the universe. Okay? Total energy, if you include all the different kinds of energy in the universe, is constant. And yet the energy in your house is not constant. That was what your dad was trying to get across. If you leave the door open or the windows open, the energy in your house does not stay conserved. Now, what I like to say is energy is always conserved, except when it's not, and it's usually not. Okay? In this case, in order to assume that the energy stayed the same, we had to ignore air resistance, that the air was not slowing down the car. We had to ignore any friction in the system that was turning kinetic energy into thermal energy. We had to make all sorts of assumptions to make that simplification that energy was conserved. Let's look at this demo here. When I was doing this demo over in Reed Hall, when it was attached to the ceiling, I would put this up against my nose, let it go, and it would literally come back and touch my nose. It was one of the funnest demos to do. Now, if you'll notice here, it comes back, it's nowhere close to hitting my nose. What's the difference? Why is it different over here than it was in Reed Hall?
Energy's lost moving the...
Oh, raise your hand. Yes.
Energy's lost moving the...
Yeah, it's lost. This gentleman, what's your name?
Jared?
What he's saying is that, watch that bar up there. And it's just wiggling all over the place. And that is energy. That's energy that's lost to the bowling ball. Okay? Now at the Reed Hall, it was attached to the ceiling, which was attached to the walls, which was attached to the ground, which was attached to the earth. And so there was nothing wiggling up there. And so the energy was pretty much conserved. I mean, there's still the air resistance, but that wasn't much.